This conference will now be recorded.
We're really excited to have folks from Planet, the imaging company, probably other things too, but to present to us about their work on wildfires. And Thomas Harris is the Director of Professional Services there. And he has been involved, or at least in contact with the Ag&Climate cluster in the past. So it's through him that we will have a couple of his colleagues present on their work on related to wildfires. So Thomas, I'll hand it over to you to introduce, I guess, first Mariana.
Oh, that's great. Thanks, Bill. Thanks for the invite today. So Thomas Harris here. I'm Director of Professional Services at Planet, and our team's all about helping customers with Planet's data and data services, helping customers be successful. But we've been doing some really interesting work lately with Google Earth Engine and integration of Planet with Google Earth Engine, and so wanted to give a presentation today on some of that work, and specifically around pre and post fire monitoring. So thanks for the invitation, Bill. Presentation is going to be presented today by Mariana Curdoglo. She's a solutions engineer at Planet. She holds a bachelor's degree in geography from California State University, Sacramento. And then Sam Roy is going to be presenting on the Google Earth Engine integration and some of the unique capabilities that are there. Sam has a PhD in remote sensing, geospatial applications, and his background in geospatial applications really has a focus on complex systems and how we can bring solutions to really solving unique and interesting problems in the earth sciences. So turning it over to you, Mariana.
Yep. Can everyone hear me?
We can.
Perfect. Yeah. So as Thomas discussed, Sam and I will be presenting. Our general agenda for today is to go over Planet. So I'll be discussing about our constellations and our platform. And then I'll also go over 2 examples of Planet imagery for pre and post wildfire assessment. And then Sam will go into Google Earth integration and go over a case study in a fire that we had been looking over in California. Traditional Earth imaging covers only a fraction of Earth's surface and is only accessible by a small fraction of people. Planet is changing this. Our mission is to image the entire Earth every day and make global change visible, accessible, and actionable. Planet is an integrated aerospace and data analytics company that operates history's largest commercial fleet of satellites, collecting daily high-resolution imagery everywhere on Earth. Planet has 2 constellations, PlanetScope Dove Fleet, which these small sats are always on and are meant for broadband monitoring. They are a 3 meter resolution, and currently we have red, green, blue, and near infrared bands. The Dove Fleet is located at the sun's synchronous orbit of -98 degrees. The second constellation is the SkySat satellites. These satellites are meant for custom and targeted monitoring. They are our 50 centimeter resolution and have red, green, and blue, near infrared, and panchromatic bands. These bands are derived by 3 overlapping cameras for each satellite. We divide them into 2 orbits. So the SkySat 1 to 5 are in the sun's synchronous orbit at -98 degrees, and the SkySat 16 to 21 are at an inclined orbit at -53 degrees. And then here you just saw a perfect example of us being able to use PlanetScope to do a broad range of monitoring, and then specifically zoom in with our SkySat to better see better in detail on what is going on. Cool. So Planet has 4 core products. They are Planet Monitoring, Planet Base Maps, Planet Tasking, and the Planet Analytics feed. Planet Monitoring provides high-frequency revisit rate with the PlanetScope Dove Fleet at global coverage. This allows for timely insights because it produces an increase in transparency, provides historical context, and helps users understand what is happening on the ground with daily imagery of their area of interest. Users get quick and easy access to pre-processed, analysis-ready imagery that easily integrates into their workflows and tools. Users have an option to choose between different types of subscriptions and to choose the one that best fits their use case and requirements. To summarize the two different types of planet monitoring, again, we have the PlanetScope monitoring, which is at 3-meter resolution. There's no tasking required. It gets daily imagery collections. It also has the red, green, and blue and near infrared bands, and they archive back all the way to 2014. And then the SkySat monitoring, which is meant for rapid revisit targeted monitoring. They are again at 0.50 meter resolution at sub-daily imagery tasking and includes the RGB, near infrared, and panchromatic bands. The archive for SkySat monitoring for some locations of Earth go back to 2014. Planet base maps are current, complete, and analytics-ready mosaics. We leverage over 1.5 million PlanetScope daily scenes to create base maps and have the ability to update these base maps on a quarterly, monthly, and weekly basis. The base maps come with a complete global coverage, which allows for an easier way to analyze broad areas anywhere on Earth. All base maps are pre-processed to be consistent, accurate, and ready for immediate use. This includes both our visual and analytic base maps. Users are able to easily access the base maps via the Mosaics API, the web tile services, or Planet Explorer. Planet Tasking is our core SkySat satellite product and is designed for rapid collection of high-resolution imagery. Planet Tasking provides you the ability to image any point on Earth at 50 centimeter resolution and gets you a demand collection of less than 15-degree cloud cover. We're able to task on monthly, weekly, daily, and sub-daily basis. Users have access to image acquisition times and can track the flow of where their task is at, and are able to retrieve the SkySat images through Planet APIs and Planet Explorer. We also do have some historical data for some parts of the globe for SkySat archive, and the accumulation of that amounts to about 10 million square kilometers. Planet Analytic feeds transform our imagery into insight. By leveraging computer vision, Planet Analytic feeds automatically extracts relevant objects and features from planet imagery. This frees up users to act on the information in a timely manner versus being able to obtain this information themselves. And they are divided into two different types. We have the PlanetScope imagery. We have the detections that are derived from the PlanetScope imagery, which are the vessel and aircraft detections. So this is based on our individual scenes, while the detections that are derived from the planet base maps are the well pads, roads, and buildings, and these are in monthly basis. So to put it all together, we are bringing you the core imagery infrastructure, the insight, and a delivery to power your decision making. And now I'm just going to go over two examples of planet imagery for pre and post wildfire assessment. Here we have a pre-fire image for Pole Creek Fire in Utah, which occurred in September of 2018. And we have two images of the fire while it was happening. Being able to observe what is happening on ground allows rescue operators to better understand how the fire is acting and to assess the best areas that need attention. We also have a post-fire image here, which allows for people to assess on the extent of the scars that the fire has caused and the extent of damage that the fire has caused. All of these are in the PlanetScope scenes, daily images, and we're looking at the false color composite. There's also an example here for SkySat. So this is a true color composite of our SkySat collect. This is for the Saddle Ridge Fire in California, which occurred in October 2015. Using our SkySat imagery, we can better understand the details of what is happening on ground. and better assess what happened after the fire has stopped. So in here, we have the before and after, and then we can also look at how it could have damaged the surroundings around the fire. Cool. Now, Sam, you want to share your slides? Sam will go into the Google Earth Engine integration.
Absolutely. Thanks, Mariana. With that in mind, before we jump into Google Earth Engine integration, does anyone have any questions, or are we doing questions?
Sam, are you there?
Can you hear me? Can you hear me? Hello? Hello? Can you hear me?
I can hear you, sir.
Yeah, we can hear you.
Okay, so you can hear me. Okay, maybe Mariana, you're having some issues hearing me. I don't know. Okay,
Hello?
with that, can someone confirm if they can hear me, Sam?
Sam, we can't hear you.
Yes.
Okay, awesome. Okay, I'm just
Sounds
gonna
good.
continue from here. Okay.
So Sam, you're asking about questions. So yeah, we're going to try to leave it until to the Q&A towards the end, unless somebody has a really pressing question they really want to ask right now. Otherwise, we'll just wait till the end.
Okay. I'm trying to figure out the screen share button. I think I have it. Got it. Okay. Can people see my screen right now?
Yes.
Perfect. Okay. So I'm gonna switch off my Slack. So what I wanted to talk about a little bit today, and going back to the presentation that Mariana had, I thought it would be appropriate if I start from here. Is to give you an idea that while we have hundreds and thousands of images, we were questioning ourselves, where exactly would you look at these images, right? Because like Mariana said, that if you think about just the mosaic itself, we're looking at 1.5 million images that we are compositing into creating a composite, right? And we also asked ourselves the question that if we were, even if we were to allow people to use these data sets through either the NASA's Data Buy program or through the education and research program that we have, or the disaster program, there needs to be a platform where they can quickly analyze these data sets. And while historically it has been easy enough to pull like the data sets as needed, depending on how many data sets are available to you, but the sheer number of data sets made life a little bit difficult when you were looking at planet data. So to kind of deal with this, and to also go into the aspect of like platforms when it comes to thinking about data, we decided that we needed to build an integration. We already had some integrations that were built into the S3's ArcGIS platform, and in terms of like downloading data and looking at base maps, we also had some integrations that was built into QGIS, similarly to look at data and to download data as well. But we also wanted to get data into Google Earth Engine, because we had heard so many good things about Google Earth Engine. I personally have been using Google Earth Engine for the last about 6 or 7 years at this point right now. So the time was right for us to actually think of an integration. So what this integration allows you to do is it allows you to basically deliver the planet images directly into a Google Earth Engine collection that you might have at your end. This bypasses the need for you to purchase a Google Cloud Storage bucket. It does not require you to, for example, basically set anything up apart from some permissioning here and there. And what I wanted to show you was that whole setup and how that imagery is going to appear for you. Now, there are a few caveats, and what I'm going to do is I'm going to exit out of this, because I did want to show you a page, which was if you go into developers.planet.com, which by the way is one of the main page where if you're ever in need for documentation, this is the place I would recommend that everyone goes. If you click on integrations, and if you click on Google Earth Engine delivery, then you will get to this page. And this kind of talks a little bit about that integration. Remember that this was built on top of the current version of Google Earth Engine, but with an extra feature which they called as Cloud Alpha. What that means is your Google Earth Engine account, where you have where you have usually been used to seeing a standard collection or like a standard root asset or something like that, in this case, every single user can have a Google Cloud project, and that Google Cloud project is linked to a 250 gigabyte standard storage. And that's where you're creating a collection. So for most people, and I'm going to show an example. I'm going to switch my Earth Engine account to one of those places where I don't have Google, like a Cloud Alpha enabled, and I'm going to show you what I mean when I say, Cloud Alpha versus not Cloud Alpha. So if I'm thinking about a standard user's account, right, you usually have a home folder, and once this, yeah, you usually have a home folder, and it is something like users underscore whatever, something, so if my name is Samapriya, so like my first name is, so it's users underscore Samapriya is like my root folder or my home folder where I have all of these data sets that I wanted to use. But if you think about a Cloud Alpha account, which I'm going to show you right now, Cloud Alpha account not only looks at these images, these projects, but my apologies, it seems this tab has frozen. And I'm just going to try to open a new tab here. Okay, so what this, if a cloud project has been enabled on your account, you no longer see just the legacy account, but you also see something called Cloud Assets, and you have a Google Cloud project associated with your account. Now, remember I told you that you don't necessarily need a Google Cloud storage. That part is still true. What I want you all to understand is that this is a Google Cloud project, not a Google Cloud storage account, okay? And everyone gets up to about 10 to 11 of Google Cloud project accounts for free. So anyone who has a Google account will be able to create this and link this. To do all of this, there's a whole setup guide that is linked here. So if you want to follow along, or if you want to upgrade your account so it can also make use of the Google Cloud Project Delivery, then you can upgrade your account to a GCP-based Earth Engine account. And there's all steps right here where you fill out the form and you ask for the license, and they're going to upgrade your form. These are some of the steps that you need to enable for you to be able to write data directly into Google Earth Engine. And the reason this is important is because if you remember in the past, Google had an interesting way of defining what a writer role is. So even though a Google Earth Engine collection, you might give someone a writer role, the writer may not have the direct privilege of writing to that empty collection. So this was done as a means of thinking about permissions in a more systematic way and then making the delivery. Okay, so we figured out what needs to happen for us in terms of Google's point of view, right? Now we need to figure out where exactly do you make the request. And again, going to Planet in GUE, there is an example here where first of all, it'll tell you like which are the images that we support right now for direct delivery into Earth Engine. We do support clips. So because that was one of those important features that you kind of wanted to have. So the way in which you will run this is you have an endpoint. You'll make a request. It will make a post request, and you have a payload. This payload or this JSON blob is the same payload that we used to send to our orders API, which is our internal API to do any kind of image manipulation in batch. But we were doing this for local delivery or for cloud delivery, like to GCS or to like AWS or Azure or something like that. We were never putting in a project name or a collection name. And now you will see that there's an entirely new section where you will see delivery, and then you give a project name. This is your Google Cloud project. And then you have a collection name, which is the same as any Earth Engine collection name. You have to create the Earth Engine collection ahead of time. Our systems does not have the authority of creating an empty collection, and we are not going to attempt to do that. So the recommendation is always that you create a collection to begin with. So in this case, what I did was I went into my account and I ended up creating a collection, which I call ESA. And I said, okay, I'm going to deliver some data here. So I created that same request, and I had some images that I knew were relevant or useful or something. I searched for those images. I gave it the item type, bundle type, which is essentially telling it what family of satellites am I looking at, what exactly is the level of assets I'm looking at. So this is surface reflectance data along with the cloud masking data, which is the UDM2. Then I'm providing it the project name. This is the project name that I'm interested in. And this collection is under that project. So ECIP was the collection. So what I'm going to do, and then I'm going to do notifications where email equals true. This is just me adding a notification because I don't want to wait and keep checking whether or not something has been submitted. Now in the authorizations tab, you would also have to put your authorization by providing your API key. I'm just going to hit send. And once this is complete, it's going to show me a URL. And what this URL is telling you is that this has been like submitted, and these products will now be attempted to submit it to our servers. Our servers are going to make calls so that to get those imagery. And once those images are ready, they're moved from our Google Cloud Storage buckets into Google Earth Engine collections for you. Now, in this case, what I'll do is I had actually made that call already. So let's see if there were some images that were already delivered. So what I'm going to do is I'm just going to run a quick size query. And there are 8 images already delivered. And if you look at it, I think there were 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 images total that were to be delivered. And if I wanted to look at it, like I can click on the ECIP collection and it should show you that, hey, I just delivered 1.35 gigabytes of data. By the way, again, it was not instantaneous. So it didn't actually occur when I clicked on submit a post request. I had made that request like almost a few minutes ahead of time, like 20 to 30 minutes ahead of time, so that I could show you that the images were indeed like delivered to the collection of your interest. So what I'm going to do is I'm just going to do image collection. Let's do first. Let's do 10. Run that. And if I wanted to just add this, and we're just going to do add layer. And if I run this, I should get a few images. And yeah, I know that they're cloudy images. Maybe for V3, V2, and run. So yeah, with this, like those images have been delivered into the collection that I was interested in. The other thing that is actually interesting about this is if I were to print the image, you might be curious, wait, but I got the image, but is the metadata actually maintained, right? And that part is really important. So if I look at the first imagery, you will see that the metadata of the object, in fact, all of the metadata that you might be looking at our catalog is actually maintained there. So like order ID, so you actually get the order ID that you use to place the order. This is the only custom metadata that we add to every single order. Everything else you can get from our catalog. So like publishing state, quality category, like azimuth angles, all of those things are included now as a part of the metadata. And the other thing I want to show you is that there are actually 12 bands in here, right? Now you might ask, wait, this is not 12 band data, right? What exactly is happening? These are the quality bands. This is the UDM2 bands that I was talking about. And essentially what they're doing is there is an 8-band, 8-bit product that shows cloud shadows, light haze, heavy haze, those kind of information. So with that in mind, that's more or less what Google Earth Engine delivery and integration is at the current state. Now, there's going to be improvements that are going to be made because right now there's only a couple of images and assets that you can deliver. I told you there's a list of those. You can't deliver base maps quite yet into Google Earth Engine. That's something that we're interested to do. We're also interested in seeing how quickly can you scale this, like what's the limitation if a lot of people want to use this. So I think it's still early days for this because we just announced it, I think, last month. So, but we're excited for people to try it and give us feedback and tell us. I am part of as part of my job description, one of my role is the point of contact for Google Earth Engine integrations within the team that I am in. So any feedback that you provide me is very useful because then I can take it back and actually work through them. Okay. So going back, we are going to do a couple of things based on the ECIP data and on the fire analysis that Mariana was talking about. Now, I do have the same imagery in the slides, but I thought it might be more useful if I just do this a little bit live. I hope that's okay. Okay, I'm gonna get rid of this code. I don't really need this. The first thing what I wanted to do is I did actually ingest a collection, and if you all are interested, the collection is literally about 92 plus images, and I have it here, which is CZU and CZU Sky. Let me just load it. Yeah, 96 images total, and they are anything up to 25% cloud cover. So mind it that we didn't end up using all the 100% cloud cover because I realized that there might be some images that are smoky, and I kind of wanted to show you a snippet that is like short enough, but it's still powerful enough to give you a message and like what we're trying to actually look at. So what this is actually doing, and I'm going to go back to a first image, is this script is essentially pulling out the PlanetScope imagery. And this is false color composite, stretched to a min-max that I had actually predetermined. But as you can imagine, for different images at different time of the year, there's going to be a different min-max, and different ways in which I'm compositing. So you can see the resolution of PlanetScope data is allowing you to see kind of like the areas where there was a lot of vegetation here. And what you'll see here is that we have created a code that kind of breaks down this collection into these weekly composites. So as I move from one week to the other, I kind of get into the situations where I'm able to look at these weekly composites. And let's see. And as I keep going further, and I'm going to zoom out a little bit, as I keep going further, you will start seeing some effects of the smoke. Because I'm creating a median composite, the smoke is also considered as part of the median because there were a few days within that 7-day period where the smoke was the true pixel median value. So it is actually added to the imagery. But what I want you to focus on is actually the post-burn imagery. So if you think about like going between a pre-burn date and a post-burn date, a platform like this makes it really, really useful and really, really powerful. And again, I'm not really trying to sell you all on like what platform to use. I'm trying to like give you a flavor of one platform where this kind of an analysis might be really easy and might be really powerful to perform. And again, this is at the 3-meter resolution data set. And so having an explorer like this, right, and having like, let's say you did want to have this every 2 weeks instead of every week, or if you were seeing an effect that you knew would happen post like a heavy rainfall event, then you could actually, instead of me selecting every weekly, you could actually trigger so that it creates a collection every time the rainfall exceeds a certain threshold. And you might be interested in specific flow regimes. You might be interested in looking at certain slopes which might be like unstable, right? And that's kind of where we were trying to get at. I think there was limited time for us to do that analysis. Just to give you a little bit more perspective in terms of like what I was trying to play around with here was also I was doing a sensor comparative. This is not a statement on like, hey, this sensor is better than other, but mostly what we were trying to do is just tell you the story on like that we love as geographers, as people who are in the geospatial world, as geologists, as people who are interested in systems. We love the idea of exploring, and this is the geometry where I'm going to add the images. We love the idea of thinking about problems in terms of scale. Nothing in our world, and I hope I'm saying this with some amount of confidence, that nothing in our world is devoid of the concept of scale. You can answer the same questions at different degrees or different scales, and depending on the scale, your data set that you're using and the questions you're asking might be different. So for example, if you're looking at a large scale burn, and if you're just looking at a Landsat data, pre and post, this might be more than enough, where you're doing basically a quick and dirty resolution analysis, like a quick and dirty analysis of like how much has burned. By the way, I could have pan sharpened them to 15 meter. That's just my bad. I didn't pan sharpen them. This is a 30 meter. But again, I could have easily pan sharpened them to 15 meter. But this is like a very quick and easy way of like looking at the Landsat analysis. There is a consistency. Landsat data is gold standards. You don't have to worry about calibrating between different sensors because there's a single satellite and you're like, well, that's not entirely true, depending on like how many Landsats collections you're actually using. But this is just Landsat SR data, and I'm just trying to show you the pre and post fire analysis, right? What I'm going to do next is I'm going to add the Sentinel-2 data. And you will immediately see an improvement in terms of like, hey, what can I see and at what resolution, right? So can I actually zoom into these areas of urban growth? Now, I don't necessarily know if these are houses or they look like industrial complexes or structures, but you can still do some interesting analysis. You can look at some urban area. And again, some of these images will look darker because remember that the way in which I'm stretching the images may not be the optimal way, and the min-max value might need to be changed a little bit. Gamma changed a little bit to make this look more amenable and approachable. Okay, so this is Sentinel-2, right? And if you want to think about PlanetScope imagery after that, from the same viewpoint, when you go into PlanetScope, the same features that you were initially unable to get, like for example, if you're looking at a road that is not necessarily a paved road, but it's still really interesting and important to you because you want to see, hey, is there enough space for an emergency vehicle to actually go there and rescue people? Or is there enough, is that land or is that road actually now cut off because there's like burning trees that's on there and you don't have the like you don't want to waste manpower, right? You don't want to waste time and like manpower in trying to figure out whether or not that road is accessible to people. That's one of those things you can do a rapid assessments of, and that's where this resolution might become interesting. And then I'm going to do the last one, which is SkySat. And this is where you truly see when you jump from like 3 meter to a 1 meter resolution. This is where you truly see like, hey, that transitions between what seems to be just pixels to me at a certain point. I can now go in and kind of do this. So if you think about it, and again, this is not necessarily like telling that, hey, don't use Landsat or hey, use SkySat only or something like that. It's kind of like talking about that idea of scale, right? Where exactly are you exploring and what exactly are you exploring becomes such critical questions that for me personally, I think that's where I usually start with. I always start with like, what is the question you're trying to solve? And what is the scale or what is the data resolution that is required? It might be a spatial resolution, it might be a temporal resolution. So for example, as Mariana said, that SkySat data are past data sets, right? So you don't have guarantees that these data sets will be collected every day on the same point every single day. But with PlanetScope, you have the possibility, much higher possibility, that you will have that coverage, even if that coverage may have some haze or some smoke in it. There's a higher probability that there might be coverage compared to Landsat, compared to Sentinel. Those things matter, and that's kind of where I was trying to get at. And the last thing I wanted to show before I wrap this up is a little bit about that, how I can quickly do something as simple as an NDVI analysis. I was hoping to pull some additional data sets where I would be showing like edge detection using OTSU. So I have some code. I was doing multi-band OTSU analysis and kind of do where change is actually occurring. In this case, for example, the redder something is, the more change that has occurred in that area. And the algorithm is smart enough that if I'm subtracting two images, you will see that the SkySat footprint is actually missing some data, or not really missing, but has a little chunk that's like gone here from the AOI, right? And if you look at the post imagery, so it kind of like, it has this amount of data that's missing from the top. So when you do the difference, the algorithm is kind of smart enough to only do those areas that are symmetrically matched between those two, the pre and post imagery. And you can do some really interesting kind of analysis in terms of like, hey, I did a simple NDVI subtraction, but does it really mean anything? Is that change statistically important? Does that actually tell me something in terms of the vegetation on the ground or the inherent effect it's going to have in terms of flow, in terms of hydrology, in terms of like people thinking about the landscape overall? So with that in mind, what I'm hoping to do is I'm hoping that people here, or people who are in the today's conversation are going to go back, and I implore you that we have a lot of these data sets available as part of Planet's disaster program. So you can actually apply for the disasters program and get access to a lot of these data sets and have them delivered to your own Earth Engine collections and do your own kind of analyses and studies. And I implore you that you actually go and explore those. And if any of you are education and research users, I process your applications every single week. So if you are applying to the education and research program, please feel free to do so. And we hope that you explore more and more in terms of like what can be done pre and post. Again, our attempts was not very in-depth in terms of getting you to a, oh, this looks like a very finished, polished product. But I was hoping that with this today's talk, I can at least get you a very rudimentary understanding of like, what is a really quick and easy way of getting to the points or getting to examples where I showed you something. And then from there, you take it much, much further and do much more complicated analysis, and as it becomes more and more interesting to you. With that, I'm going to mute myself. And if there are questions, I think me and Mariana can take a few questions.
Yeah, thanks, Sam, Mariana. Before we get into the Q&A from the audience, I thought it'd be good just to provide some framework for the Q&A. I'm just going to take like a minute to to kind of talk about why our group, the Agriculture and Climate Cluster of ESA, is doing with wildfires. Right? So there are several reasons. So the Forest Service, of course, is part of USDA, right? So that is the USDA part of it, and also obviously all the climate change, the crisis aspect, is of course directly related to wildfires. And also, lastly, we've been, particularly since the beginning of this year, looking at using tools such as concept mapping and knowledge graph and ontologies to look at data to decision relationships links. And wildfires was one of our first use cases in that effort, which is still ongoing. And lastly, more recently, we're looking at the Sustainable Development Goals. Goal number 2, of course, is zero hunger, which was obvious one that we would look into. But there are other goals and tasks that relate to disasters, which include wildfires. So that's kind of a quick history of why we're looking at wildfires from an agriculture and climate perspective. I have a list of questions, but I'm just going to ask one, and then I'll let other people ask. So Sam, you mentioned about the I guess the analysis ready, right, data, and I was just wondering if, like, for people on the ground, particularly the first responders to wildfires, like, have you worked with them, and how, like, what would they need on the ground to be able to benefit from planet images in a real-time or near real-time basis? So these would be like the, people, the bear team from, say, the National Weather Service, who gets on the ground, right, and post-fire immediately, and they need information about their surroundings. So, like, what would they need in terms of resources in order to take advantage of what you have, and have you worked with those people, those teams on the ground?
Yeah, usually I'm on the other side of the table because they tell me what they need. I'm usually answering them like, yes, we have this available. But yes, we have worked with organizations that are doing fire modeling as well as simulation, as well as some real-time assessments of fire data that might be available. And I think what some of the feedback that I got was where Planet data was really useful was that even if there is a lot of smoke on the ground and you don't have like sewer bands and things like that, but you're still able to get a lot of imagery coming in every single day. So as long as you have additional images coming in, you might be able to get peek and glimpses of areas that have been burned, and you're able to do a much more rapid and much more accurate assessments of where exactly is the edge of the fire, because that's one of the harder things to do when you have a coarser resolution pixel. That being said, I think there's also some experiments that I have seen. People are now venturing into fusing optical data with SAR data. So I would love to see some more examples in the future of where people have attempted that and people have made strides in doing that. And And I think that's kind of where we are targeting in terms of looking or thinking about fire data, at least with the limited experience that I have. Because like I said, Bill, I think we usually are called upon after there's once a fire event actually occurs, there's like a charter that is activated, an emergency charter notification occurs. Then there are these organizations or companies or people who reach out to us and say, hey, I need help in like rapidly getting data to you. And one of the most important and critical thing is the delay in getting data, because the moving the data is heavy. Getting the data in a format that is easily accessible and readable by whatever systems you're using on the ground becomes critical for us. And I think we are trying to move in that direction, where we are trying to integrate with as many platforms as possible, so that you don't have that burden of moving or writing custom anything to moving around that data. Does that kind of answer that question?
Yeah. So the planets involved will come after. So people on the ground, by that I mean, the actual firefighters, right? So in the moment, they need kind of situation awareness information. So
right.
So it's like your involvement is post that the firefighters period.
So you can have involvement before the event. Usually we don't directly communicate with the firefighters, I'll be honest. We have an organization or two organizations. The organizations will reach to us, and then they will decide on how to disseminate the data. So we don't necessarily work directly with like telling the firefighters that, hey, on our latest satellite images, we see this, because like I said, we are not, I'm a hydrologist by training. I'm not someone who is an expert in fire. But I love that there are colleagues and there are people in other organizations who are those experts, and we want them to make those interpretations. But what my role is to get that data as quickly as possible and to screen the data in ways that makes most meaningful sense for them. That's where we come in, or that's where I come in and kind of like do that extra custom bit of like, hey, this let me help you in this way or that way. You could plan ahead.
I can maybe add something there. So I know,
go for it. Yeah.
Bill, that we've worked with some organizations like CAL FIRE in California last year when there were fires. They came to us, and I think one kind of workflow there is their operations center just accessing our archive and current imagery through Planet Explorer. Sam, you might just share your screen and pull up Planet Explorer real quick. That's our online tool that allows folks to browse our archive. And so the most recent imagery there is going to be right at around 24 hours old. So it takes about that long to get imagery down from the satellites through our system and published. But that's one method. And then Sam mentioned the integrations, so making it easy for people that are consuming Planet data to pull that data into systems like ArcGIS, so that enterprise like CAL FIRE, who has a big investment in the Esri technologies, could just seamlessly pull that imagery into Esri and then publish it out so that people in the field, firefighters in the field, could access it. Yeah, here's Planet Explorer.
Yeah, I was just trying to pull in some data and show you like how you can switch between like different dates of data. And every dot here, by the way, represents that there is some observation, and I can narrow down the geometry so that it's a smaller geometry, because right now it's including multiple images. So if I go into a single geometry, you'll see that at the bottom, all of these dots represent a day's worth of observations, so you'll get near daily observation as much as possible. The way in which the images look in Explorer aren't necessarily the way in which the full resolution 16-bit images will look at your end. This is just a thumbnail view because we're creating rapid thumbnails on the go. But this is kind of the way in which users can browse through the images and say, I am interested in looking at data from this aspect. We also work with some agencies. I know for a fact that there is it's Pyrogens or something, I forget the name. There is actually a NASA Severe funded project where we were looking at this work where they were trying to simulate, like model out where there might be high fuel availability. And based on this fuel availability, they were doing some models where they were coming up with the risk of fire starting at specific locations, not just based on fuel, but some other aspects. So we also help with those as needed, and as these researchers and organizations come to us.
Great, thanks. Anybody else with questions?
Yeah, this is Brian, and I would like to ask and extend your previous comments, both Sam and Tom, about working with agencies. So the question has to do with where you guys are currently involved in what I'm about to describe, or whether you see yourselves having a role in what I'm about to describe. So the USDA and the Department of, well, the USDA operates this thing called the GTAC, the Geospatial Technology and Application Center, GTAC. And the GTAC is commonly the place where, forest service managers and folks on the ground who are responding to an incident, they go to the GTAC to try to submit a request to say, look, there is a fire in this national forest. We need a burn assessment, as in like a burn severity assessment, in the next 48 hours, so that the Forest Service can submit a report. And Bill had mentioned this report, BAER, B-A-E-R, the Burn Area Emergency Response Report. The Burn Area Emergency Response Report is meant to propose remediation for the burn area, right? So once the fire is contained, what should the Forest Service do in order to prevent things like landslides, right? So that's the BAER. So the GTAC, the GTAC, will respond to a request from an agency to get them burn area data. Now, so where do you guys play in this picture with the Forest Service or with the Department of Interior? Because at the Department of Interior with the USGS ARIS Data Center, the Earth Resources Observation and Science Center in South Dakota, or is it North Dakota? One of those two. Anyway, the USGS ARIS Data Center are the guys who will take remotely sensed data to do burn severity assessment in conjunction with the GTAC that I mentioned, the Geospatial Technology and Application Center of the Forest Service. So where in this orbit do you guys play, either now or do you foresee yourselves playing in the future?
I'm going to try to answer this to the extent that I am knowledgeable of, and Thomas, you can jump in anytime you want. So I don't know that we have worked with GTAC in the past, but we do work with the Hazard Data Distribution System at USGS. And we have made data available to them on request using the open charter that we are a part of. So whenever there's a charter request and they request data to be delivered, we've worked with them in the past, and that data gets ingested into the HDS system. Now, working through GTAC, I think that is a question for, so we have two entities within our company, and there's an entire team that is dedicated to looking at our federal relationship. So there is actually a Planet Federal team. And Brian,
Sam, we have Vince Hurley on from that team.
Oh, Vince is on the call. Okay, never mind. Vince can answer that.
Yeah, so Vince, you want to jump in there?
Sure. Hello, everyone. So we have had conversations with the GTAC over the last year since I've joined the Planet team. We've also had a lot of conversations with the Forest Service. In particular, we've talked to Everett Hinckley a couple of times, and we're also dealing with some of the U.S. Forest Service regional geospatial teams. And a lot of the conversations, they completely get that our data it can be helpful, but is not necessarily the #1 choice when there is a fire burning. I think the question was centered around how could we help do burn scar assessments and then help them look at post a fire at the impact to the forest area itself. And then we have had some conversations with a couple groups, actually in the last about 2 months, about could our imagery also be used for assessing where there could be landslides and things like that after a fire's gone through. So most of our conversations have been, what could we provide for imagery pre-fire? So if they need to go see what was there before or do an assessment, they've talked about getting that set up. And then they've talked about, like I said, a couple cases post a fire. How could they do assessments of, and we're looking actually at a project with the Forest Service where there's going to be some prescribed burns next year. And they're considering both our PlanetScope and SkySat imagery, how they would, with those prescribed fires, because they'll know the date and time things when they're being done, take some more, run some trials, run through their processes, and attempt to integrate our imagery into those. I think it was Brian. Did that help answer your question?
Yeah, thank you. So these conversations, in other words, have been initiated and they are ongoing.
Yeah, we're just trying to find the right, mix of the use cases, and then, as you all know, then engaging in the contracting process, which can be timely at times. But yeah, so I think we're in that beginning phase.
Okay, thank you.
Anybody else with a question? Thomas, in our leading up to this, you guys presenting, we talked a little bit about, via email about, sustainable development goals, and you had indicated that you guys are just getting into that a little bit. I was wondering if you could just mention a little bit about what is it that you guys are interested in that space, and what are you planning to do, there?
Yes. So, I think at Planet we have a deep interest in the Sustainable Development Goals, and definitely see a place where Planet data can add a lot of value there. Just our global coverage, the temporal cadence of collection for Planet data lends itself to being able to address some sustainable development goals and indicators that are used to drive the sustainable development goals. We see an opportunity for the data to be valuable there. Our team and others at Planet have done a bit of work in the past looking at specific SDGs. For example, SDG 11, sustainable cities and communities. And, for example, looking at urban area growth and urban area density as it relates to population. I'd say our work there is preliminary, so we've barely scratched the surface, but I think there's great potential.
Great, thanks. Yeah, looking forward to see what you guys do there and the progress. So for us, we're also relatively recently kind of looking into the different goals that are relevant for to our interests, goals and tasks, and so this upcoming Easter winter session that we're organizing will in part be dealing with that. So
we'd love to chat more about how we might participate there.
Yeah, in fact, we adding to what Bill has just said, and you mentioned SDG 11. So there are 2 specific targets within SDG 11, And there are 1, 2, 3, 4, 3 targets within SDG 13. I don't know, I can't remember if you mentioned SDG 13, but yeah, we actually focused on a couple of specific targets within SDGs 11, 13, and 15, where we are interested in, well, one of the possible things that Bill mentioned earlier was, tracing how data is used to inform decisions. So that's within the scope of what we are trying to explore this coming year with regards to how linking data and showing the traceability up to models, and from models to publications, and publications to assessments, and finally either policy or management decisions.
Very cool, very cool. Sam, did you have anything to add on our work around SDGs?
Oh, I think Sam had to drop off. He sent a message that he had to drop off right now.
Ah, there we go. I see it.
Okay, I have top of the hour at 4. Anybody has any last minute pressing questions before we sign off?
Hey, from our side, just thanks for the opportunity, Bill. It was great to speak with everybody. Thanks, Mariana, for your efforts here. Also, thanks go out to Sam, even though he's dropped off.
Yeah,
Thank you for having us.
Thank you, guys.